G'day everyone, Glenn from Sequential Automotive and Auto Electrical again here for another edition of Scoping and Probing. Today we've got a Nissan Navara D22 2005 model with a problem of a crank and no start. It's come to us with already had the timing chains replaced. You can see it's even got a new cover there, and also a new injector pump that's been supplied and fitted, and it still has the same issue of a crank and no start. Interestingly enough though, if you do spray brake clean or some aerostart in the intake, it does actually start and run, and it'll be fine until you turn it off and go to restart it again. I've actually already know what's wrong with this thing, but it's this car, but it's one of those ones we get probably most calls for on the forum, and that is starter motor generating interference with the sensor, which prevents it from starting due to electrical interference. So I'll show you initially what the problem is, and then I'll show you the best way to go about diagnosing it and then potentially fixing it. So what I've got here is on channel B on the blue scope is a back probe pin into the crank angle sensor, and on our main battery harness I'm going to put our cranking current clamp over the positive terminal to measure the cranking amps from the starter motor, and then go to the scope notes when I crank it. Okay, so I'll just rewind this. So first thing to note is that the relatively high amount of current draw coming from our starter motor. So generally most petrols will probably draw a 4-cylinder around 100 to maybe 120 amps of current. Diesels maybe go up to maybe 200, 220. But as you can see, this here is peaking probably close to 400 there on this high peak, and low down to 100 and 110. So straight away you can probably hear it as well. It was making an unusual noise, or a high pitched noise, and that's mainly because the starter motor is drawing so much current. So if we zoom into our crankshaft position sensor. So these little, these points here are top dead in the actual crank sensor, a position of where it's supposed to be. You can see there's an AC signal there, and there. What you've got here in the middle is a lot of hash, and that hash is directly proportional to the amount of hash coming out of the starter motor. So this is interference caused by back EMF generated because there is so much current going through the starter motor, and that puts current back into the whole system, and it's actually reading that, and that back EMF, or electromotive force, is counterintuitive to that sensor being read by the computer, and therefore knowing when to start the injection process. So if we just go back to see what perhaps it should look like. So these green peaks and troughs are the current draw coming from the starter motor. Obviously the peaks are when it comes up to compression. And if you can look here towards the end of the trace, this is what the peak should look like without interference. So when the green hash is stopped here, that's when the starter motor actually disengages from the engine. And these peaks and troughs here are the engine still rotating without the starter motor. And as you can see, it's a much cleaner picture now without the hash induced by the starter motor. So as you can see, these are slowly decreasing in amplitude because the engine is actually slowing down as it gets further along. So we'll just go back and look at that as a whole. So again, cranking, a lot of hash. Computer can't differentiate where to start the cranking, the injection process, because it can't read this signal properly. So what I'm going to do now is I'm going to disconnect the starter motor from the battery of this car and put my own battery to the starter motor purely to crank the car with the starter motor, and the rest of the electrical circuits will be coming from the car's original battery, and we'll see what sort of picture we get. Okay, so this is my jumper lead. So what I'm doing is pulling off the main battery power cable going to the starter motor. That one there, I'm going to put mine on. If I can just get a bit of the light down there. Put that on. Just do that up a little bit tight so it's got a good connection, given the fact that it's drawing nearly 400 amps. Okay, so that's on the starter motor. So what I'm going to do is hook up my 12 volt direct supply to the starter motor. Out there. Black one to earth. Put it there. And my current clamp I will now put round my jump wire to the starter motor, while my other accessories, computer and so forth, and fuses are all still going off my original battery. Okay, as you can see, that actually started. So we'll go back and have a look at our difference. Okay, so you can see our crank is still, our starter motor is still pulling around over 400 amps there, 390. But you can see our picture has improved a lot. There's a lot less hash there now. Okay, so that at this stage, the computer can see the difference between where the peaks and troughs of the AC signal is compared to the hash. And it's a much cleaner picture, and the computer can make sense of where the injection process is now supposed to start. Again, if I go back, you can see when the car starts to run, you can see that the AC ripples, the AC signals are much broader and cleaner. So what I'll do now is, now that I know that starter motor is causing the high EMF cause where that starter motor is causing our problem, I'll get a new starter motor, put it in, and we'll measure the cranking amps of that starter motor. G'day, welcome back. We've got the new starter motor in and ready to test. So I've got a brand new original Hitachi starter motor down there, all bolted in, and we've still got it hooked up to our crank sensor and our current clamp over the battery. However, I have disconnected the injector pump because this, of course, now starts and runs, so I don't get much time to, I only get a great deal of time to crank it before it shows up, starts running. So I've disconnected the fuel pump while I crank it and see how we go. Just start that. Okay, and as we can see, let's go back to that page. There's really no hash there at all now. You can see a little bit in our crankshaft sensor. That's just purely hash due to the way the scope's set up. If I put a clear on that, it'll be fine. So if you look at the current draw is still higher than I thought it would be. It's around 300 amps. But as you can see, there's no hash, there's no binding up of the armature to stator, and therefore causing that hash. And the pictures, the peaks and troughs of the AC inductive sensor are much more prominent. So if I just make that a bit bigger. So you can see the spikes between the peak to peak on the AC sensor are much higher than the rest of the hash in that circuit, and there's nothing to interfere from the starter motor current draw. That's it for this episode of Scoping and Probing. So remember, if you think you've got a starter motor issue inducing some sort of interference, just try and bypass if you can. Otherwise, get onto oscilloscopes and start scoping and probing. Thanks for watching.